Good morning. It is Wednesday, March 18th. A number of you expressed some difficulty with the solving logarithmic equations assignment. So this is totally optional. I'm just putting up a couple of extra practice problems. I want to talk about two cases that you're going to come across a lot. And once you recognize those cases, you'll start to see that there's a pattern. They're all kind of approached the same way. So number one says log base 8 of x plus log base 8 of x plus 6 equals log base 8 of 5x plus 12. So we've got base 8 all the way across the board. We can condense the left side of our equation by multiplying our arguments together. The two logarithms are being added, and that addition rule tells us that we can condense those into one by multiplying their arguments. When you multiply x times x plus 6, remember that you are multiplying x times a quantity, which means you need to distribute that x. So x times x is x squared, and x times 6 is 6x. Okay. And on the right side of the equation, log base 8 is 5x plus 12. Okay, so when you get to the point where you have a log on both sides with matching bases, you're pretty much always going to disregard the log and set the arguments equal to each other. Something to watch out for is if you get a square. If you get an exponent of 2, sorry, I'm losing my voice a little bit. Let me get some water. If you get an x squared in there, it's going to be a trinomial. You might have to factor. So if that's the case, always move everything to the left side or everything to the right side. But in this case, you want the x squared to be positive. So move everything over to the left side and set it equal to 0. X squared. So 6x minus 5x is 1x minus 12 equals 0. So that's kind of the pattern that you'll need to start noticing, that if you have an x squared, you're probably going to have to factor, which means you have to set your equation equal to 0. And then when you think of what multiplies to negative 12 and adds to positive 1, I know the combo is going to be 3 and 4. And in order for those to add to positive 1, my 4 needs to be positive, my 3 needs to be negative in order to have 1 positive left over. So when I set my two equations equal to 0, x is positive 3 or negative 4. Now, technically, I'm supposed to take this negative solution and plug it in. If you plug in a negative solution and it gives you a negative argument, you have to disregard that answer. You can't actually take logs of negative numbers. But at this stage in the game, I'm not so much worried about that as I am practicing how to solve. So I'm going to leave it there. X equals 3, x equals negative 4. So again, if you see a log on both sides with the same base, odds are you're going to disregard that log, set the arguments equal to each other. If you see an x squared pop up, odds are you're going to need to factor, which means you have to set your equation equal to 0. Next one, log base 4 of 3x minus 2 minus log base 4 of 4x plus 1 equals 2. This is the other type of problem that you're going to come across a lot when you have logs only on one side and not a log on the other side of the equation. We see that the logs are being subtracted. They have the same base. So I'm going to start by condensing them by dividing their arguments. It's always going to be the first log over the second log. And when you get to this step, if you have a logarithm on only one side of the equation, then you have to start telling yourself to change it to an exponential equation. There is no log on this side. I can't disregard it and just look at the arguments. So I have to rewrite it as a base 4 raised to the second power equals 3x minus 2 over 4x plus 1. This is the other trick. So you're going to see these two types of problems occur a lot, and they all kind of have to require the same series of steps in order to get your final answer. 4 squared is 16. I'm going to multiply both sides by 4x plus 1. That will eliminate the denominator on the right side. And when I multiply by 4x plus 1 on the left side, I have to remember to distribute that 16 to both things inside my parentheses here. So 16 times 4x is 64x plus 16 equals 3x minus 2. And now you're left with a linear equation where you can solve for x. Subtract 3x from both sides. subtract 16 from both sides. Let me make sure I did my math right. I hope. Hopefully it comes out to a round answer. 18 over 61. Let me just double check because I feel like I may have made a mistake somewhere. 4 squared is 16 times 4x plus 1. 16 times 4 is 64. 16 times 1 is 16. 3x minus 2. Subtract 3x from both sides. Subtract 16 from both sides. Okay, unfortunately it's a fraction. If I did my math right, I think I did, but if you find a mistake, please let me know. Negative 18 over 61. Can that be reduced? No, it can't. Okay, so not a very pretty answer, but a correct answer nonetheless, unless you find a mistake. If so, let me know. Bonus points for you.